Hi kids, today we are going to be looking at finding common denominators. I want you to go ahead and pause the video and write down what you see on the screen as part of your notes so that you have a point of reference. And we're going to come back and talk about what this definition is. Go ahead and pause the video. Okay, now that you have written down what a common denominator is, we are going to look more into what this means. A common multiple of the denominators of two or more fractions, and these fractions are going to have the same number of parts or equal pieces, and this is represented by the denominator. So let's take a look at that. We are going to now write these pairs of fractions as a pair of fractions that share the same denominator, because we want the denominators to be what they have in common. Right now, when I'm looking at the denominators, I see that they are 3 and 4, and these denominators are not common. So I need to make them common to one another. And the way that I'm going to do that is that I'm going to find common multiples. In class today, you did the activity where you used sheets of paper to represent cakes. One sheet of paper represented a cake that was cut in half, and the other paper represented a cake that was cut into thirds. And this was your visual representation of finding common multiples. Right now I want us to look at common denominators. Right now I want us to look at finding common denominators by finding the common multiples. So if I look at 2/3 and 3/4, the first thing that I want to do is find their common multiples. And we learned that common multiples are the numbers we're going to count by, or skip counting. And common multiples can also be represented in multiplication. So if we find the common multiples of 3, we know that we will have 3, and the next number would be 6, next would be 9, 12, 15. And I am going to use 1, 2, 3, 4, 5 multiples. I'm going to stop at 5 for each of these examples. I can also say that these multiples are represented by multiplication, because 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9, and so forth. This number 4, we're going to skip count by 4s or multiply. 4 times 1 is 4, and then my next multiple would be 8, and my next multiple would be 12, and my next multiple 16, and the next multiple 20. And I'm going to stop here. I have my 5 multiples represented. Now I'm going to see what they have in common. And I look through my multiples, and I can see that there's a 12 here, and there's also a 12 here. And so this is the number or the multiple that they have in common. And so I can rewrite these fraction pairs as a new pair of fractions with common denominators. So I can rewrite the 2/3 here with a denominator of 12 instead of 3. And I can write the 3/4 here with a denominator of 12 instead of 4. Now when I do that, I need to show how I changed the numerator, because remember, the denominator used to be 3, but now it's 12. And I know that this denominator became 12 by multiplying by 4, because 3 times 4 is 12. Now, since I did that to the bottom, which is denominator, I must also do that to the top to also show that. So I have to multiply the numerator by 4 as well. So that will change this fraction to 8/12. So now 2/3 is 8/12. And I need to do the same here. This 4, remember, denominator is now 12 as well. And that happens because 4 times 3 is 12, and I have to also multiply the numerator by 3, and that is going to give me 9. And so now this fraction, 3/4, is represented as 9/12. So I have a pair of fractions. It's two fractions, a pair of fractions that I have represented with common denominators. And so I have followed these instructions. I have written a pair of fractions as a fraction pair with common denominators. That's what I did over here. And if I go back to my meaning, my definition, it says that the common denominator is a common multiple of denominators of two or more fractions. So I have two or more fractions. So I have at least two that I'm representing here, and the fractions have the same number of parts or pieces, and they do, 12. They both have the same number of parts or pieces, which would be 12 in this case. Okay, let's try another one. Here we are going to represent 1/2 and 3/10 as a pair of fractions with common denominators. So again, I'm going to find the common multiples. So this one I'm going to count by twos: 2, 4, 6, 8, and 10. And I'm going to only go up to those first 5. And here I'm going to do the same: 10, 20, 30, 40, and then 50. And I'm going to stop there. I'm going to check and see what they have in common, and I see that they both have a 10 in common. And now this is going to give me my common denominator. So I'm going to have a 10 here and also a 10 here as my denominators for both of these fractions. Now I want you to pause the video and see if you can finish the rest. So that means you have to figure out the numerators. So go ahead and pause the video and find the numerators. Okay, let's see how you did. Now, if you've gotten this far, you're right on track. We need to show that 1/2 is represented with a denominator of 10. How is that? Well, we can see that 2 times 5 is 10. Or I can look into my multiples and I can count 1, 2, 3, 4, 5. The 5 is in the 10. The 10 is in the 5th position when I was counting by twos. So now I know that that can be 2 times 5. Times 1, the 10 is in the 1st position when I was counting by tens. So it would be times 1. Now we can go ahead and 1 times 5 is 5. 3 times 1 is 3. And we have our new numerators and our new common denominators that represent our new fractions. 5/10 and 3/10 are a pair of fractions written with common denominators. Now we are going to move on to equivalent fractions, and we're going to look at those same two pairs of fractions to see if they are equivalent. And you've already done some work with equivalent fractions, and so we are going to see how we can use common multiples to determine if the fractions are equivalent, as well as look at the way that we can just use multiplication to determine if fractions are equivalent, which is the work that you've already done. So if we were looking at multiplication, I can start with the numerator of this fraction or the denominator, and I can simply try to figure out if I can multiply to get the new fraction. So 2 times something, is that going to give me 3? Or is 2 divided by something going to give me this 3? And I can clearly see that that won't work. And so if it's not going to work for the numerator, let's try the denominator. Is 3 times anything 4? Or is 3 divided by anything 4? And I can look at this and say, no, that will not work at all. If we found the common multiples of 3 and 4, and we've already done this work, we found the common multiples of 3 and 4, and we know that the common multiples of 3 and 4 is 12. When we change these fractions as a pair with common denominators, Remember what we did? Remember what we got for 2/3 and 3/4? Well, when we started out, we were here, and for 2/3 and 3/4 we said it was 8/12 and 9/12. So we've already done the work, and we can see these fractions are clearly not equivalent. So when we're looking at these two fractions, we know that they have a common multiple of 12. That we know. So the denominators are going to be the same. When we see that, we're going to have 12 for this denominator and 12 for this one. But our numerators won't be the same. So we had 8 here and we had 9 here. And these fractions are therefore not equivalent. Why don't you pause the video and tell me whether 1/2 and 3/10 are equivalent or not. See if you can figure that out. So go ahead and pause the video. Okay, let's see how you did. Again, we can look at these fractions and we can start wherever we want. We can start at the numerator, we can start at denominator. So let's start at denominator this time. Is something times 2 going to give me 10? Of course. 2 times 5 is equal to 10. But I have to also multiply the numerator by 5. And 1 times 5 is not going to give me 3. So I can see that these fractions are not equivalent. Or I can look at what the common multiples were, and we know that the common multiples were 10 for these. And then I needed to also go back and do what my numerators would have been, because this did not work. We can see that when we tried this, it did not work, so that wouldn't work. And also when we worked on this over here, we can see that we got 5/10 and 3/10. So again, these fractions would not be equivalent. Okay? Now I want you to do some practice on your own. You are going to look at these problems. There are a total of 4 of them. I'll scroll up in a minute so you can see them. The first 2, you're going to write these fractions with common denominators. So these are a pair of fractions. You're going to write an additional pair of fractions with common denominators for 1 and 2. And then when you get to 3 and 4, you're going to tell whether these fractions are equivalent or not equivalent. And this will be a review of your work with equivalent fractions already this week. Go ahead and take care of this assignment. Remember to show all of your work in your journal. Remember to log into Edmodo and let me know that you have watched the video. I hope you have a great rest of the week, and I can't wait to see you all back on Monday. See you soon.